right, we're here at the DevOps Talks conference, and Aaron, we've just had a talk from you. So first, can you introduce yourself for us?
Yeah, so my name is Aaron Bowden. I'm a customer engineer here with Google Cloud in Australia. I'm a customer engineer, so that is basically a pre-sale solution architect. So I go out there, work with different customers, understand their problems, and help them understand how to use GCP technology.
Awesome. And was this your first DevOps Talks conference?
It was. I had heard of the previous one in Melbourne through a colleague, and I was actually really excited for this one, so I made sure I was able to put something together that was able to speak to the engineers in the audience.
Absolutely, and it's always good to have a nice technical talk and really get into sort of the meat and potatoes, if you will, of the technology. And I thought it was really good that your talk also sort of blended two different technologies that are complementary to one another.
Yeah, I think that's one of the things. People sometimes think that public cloud providers are all about locking you in. It's actually, especially with GCP, it's really far from the truth. So there's a lot of open source technology and a lot of work that we're doing with other companies like HashiCorp, just making sure that you can use the right tool for the job, essentially. And you can see in the talk that I did today, I was using Terraform to orchestrate, and I was then also using HashiCorp Vault for the secret management, which was the main point.
Yeah, and as it was your first DevOps Talks conference, how did you find it?
I actually loved it. I really like the theme that's starting to come through DevOps, is that it's not new anymore. People are actually going, all right, well, we can run this fast, but now how are we actually going to do things securely? How are you actually going to run a business? I think there were a couple of talks around there also, not to forget the business impact of what we're doing. And I think that's actually really refreshing. Yeah,
so we can take some of the practices that have emerged and actually apply them to real business value.
Yeah, exactly right. So no point doing technology for technology's sake. Right. We'll all be out of jobs.
Yeah. All right, Aaron, thank you so much. And thanks
for
presenting.
Much. Yeah, thank you very much.
Cheers.
Thanks.
So if this talk sucks, you can just head right over there and probably break in and grab something to drink. So either way, you win. Cool. All right. So my talk today is on lessons learned around embracing DevOps and cloud security. Let's give you a little bit of background and then just jump in here. My background's all in security, so I started out in security consulting and pen testing. If you know ISEC Partners or NCC Group, I was there for a long time. And then got given a really unique opportunity to go be the first CISO at Etsy. At the time when it was Etsy in New York and Netflix in Silicon Valley that were kind of pioneering what we now call DevOps and cloud. So I got to be one of the first CISOs to go through that shift, which was an exhilarating time, we will say. And there was a lot to learn out of that shift. It basically changed the way we've been doing 20 years of security. And as we were there at Etsy, myself and what became my co-founders, we really needed some more modern ways of defending our web applications, our APIs, and eventually microservices and things like that. We got really fed up with the legacy web app firewalls. So if you know Akamai or Imperva or F5, they're firewall offerings that kept breaking our apps and not having cloud-friendly architectures and everything there. So we ended up spinning out from Etsy and taking a bunch of the lessons learned, turning that into a product. That's Signal Sciences. So we make what the marketing folks would call a next-gen WAF or a RASP. You can drop in to defend your applications without false positives and having a modern architecture. That's not what this talk is about. No one needs yet another vendor pitch. That's the last you're going to hear about Signal Sciences, but if that's relevant to you, happy to talk more about that later on. This talk is really the lessons learned I wish I could have given myself on day one of going through a DevOps and cloud shift, which is really, we have all of these different ways in which we try to secure and defend the applications that we're hosting. And almost all of those were really built for a waterfall and data center world. And so how do we modernize the kind of key pieces of the software development lifecycle or the security development lifecycle and move from that waterfall world to the DevOps world? Are there any folks in here who are, I'm curious through the audience, are there any folks who are full-time security roles versus DevOps roles? Awesome. All right. Cool. I was wondering what the balance was. So I'll give you the kind of spoiler right up front, which is really that security goes from being a gatekeeper and a blocker to really focusing on how does it enable teams to be secure by default. If there is one kind of high-level thing that I hope you take away from this talk today, it's this shift. This is the existential shift that is happening in security right now. So this is really what the theme of the talk today. So what has changed? I mean, this is a room full of DevOps folks. I do not need to spend 18 different slides on trying to explain what DevOps is or anything like that. But I'll tell you kind of from the security perspective, a couple of things that really jumped out to me going through this shift. So number one is that change now happens orders of magnitude faster than it used to. So this was made incredibly apparent to me where my last project where I was doing security consulting and pen testing was at a place that did waterfall deployment. They would make production changes once every 18 months. It was a huge US healthcare company, and we'd come in and we find all these massive vulnerabilities on like the front page of their site, and they'd say, yeah, that's great, we'll get to that in 18 to 24 months. I'm like, okay, glad my patient records are in there, that's awesome. Pro tip, maybe don't put a live Ethernet port in the parking garage. Crazy idea. Yeah, let's go nuts. So I left there on a Friday. I took no time off because I'm an idiot. I started at Etsy Monday morning, and they sit me down. This is what, 2009, 2010. And they say, great, yeah. We deploy to production 20 times a day. Figure out security, go. This was at a time when Facebook deployed like once a week. And so there was nothing to Google, there was nothing to read. Basically, as you will see through the course of this talk, I basically just had to screw a lot of things up for a very long time to find stuff that actually worked. And so that's kind of I'd say the first big lesson here is that change is not just kind of gradually, it's not a gradual rate of increase, it's increasing exponentially, right? And it's happening multiple orders of magnitude faster than it used to. And the other piece is really this decentralized ownership of deployment, which is that in the past, all of these different key areas would function by really being outsourced groups. So you would have development teams writing code. It would get thrown over the wall to a QA team. It'd get thrown over the wall to a security team, to a performance team, eventually to a SysOps group to go to staging, and then pre-prod, and then production. And issues were found along the way, and it kept kind of coming back to the development team and then going back through the journey there. And there were all these different functions that were their own isolated silos. And so the other kind of big change I'd say in this world that we're going into is that those functions don't go away. They just don't function as outsourced groups anymore. Right? We don't stop testing our code. We don't stop caring about security. We don't stop caring about performance. It's that we need those capabilities directly embedded inside the development teams and the DevOps teams. And this is a huge change. And I think for a lot of those other groups, it's something we've been doing for the last 5 to 10 years and really started to have a bunch of lessons learned. Security is much earlier in that change. So to that point, I think the biggest change for security is that it can no longer be outsourced to. It's always been built around this concept of being a gatekeeper where security signs off on something before it goes out or a big change happens or anything like that. Security's #1 goal as an organization actually fundamentally shifts now to making the rest of the organization security self-sufficient. This completely changes the way that we've done security for the last 20 years. So it's going to be messy along the way. But it can only be successful if it can actually bake into the development, into the DevOps teams. And so I think that it's actually really at this point where like IT procurement teams were at the start of the rise of cloud, where you would come from the development side or the DevOps side or the business side and say, hey, we've got this whole new business initiative that our CIO is pushing forward, needs to be live in 6 months. So we need to requisition a bunch of servers into one of our data centers so that we can get going. And the procurement team would say, yeah, no problem. We'll get you those in 15 months. And you're like, okay, well, how about I just put down a credit card and be up and running in Amazon or Google or Azure or whatever in 5 minutes. And so they just got completely routed around. That's where security is right now, where I see this happening in a bunch of Fortune 500, Global 2000 companies where the security team, I'll go in and I'll talk with the CISO, and I'll go in and I'll talk with the CIO and the CTO. And talk to the CISO, and they're like, yeah, we don't do that cloud thing here. It's not secure. We don't do it. And then you go talk to the CIO, and they say, oh yeah, we've been operating in the cloud for 18 months. We just don't tell those security idiots anymore. Because they just get in the way. And you're like, okay, yeah, some change has happened here. And And so this is the point where we're at this change, where if security can't bake in and can't actually enable the business to move faster, the business isn't going to stop operating. It's just going to stop talking to the security folks. All right, so I've got a highly technical flowchart of what that actually looks like when you just bring the legacy methods across here, which is the security train plowing into the DevOps car while shouting about safety. I think this is probably my #1 favorite description of the security industry. I say that as someone who's spent my entire life in the security industry. It sums it up very well. All right, so what are the common pieces of a SDLC? These are, if you look at it from a macro level, everybody does the pieces kind of different, but from a macro level, these are the things that we tend to go through as technology organizations from a security perspective, which is we'll do some training, we'll do some kind of attacker modeling or threat modeling, design review, on and on and on and on here. So this is a 40-minute talk or so. There is no way to get through all of that. So what I did is I'm just focusing in on a few of the ones here, the ones in bold. So static analysis, dynamic scanning, visibility, and onward. These other pieces definitely change. Happy to talk your ear off about those as well some other time if that's interesting. But I'm just going to focus in on here just as a function of time. And so what I'm going to do is I'm going to have a slide or two on how we've been doing this, and then a few slides on how we adapt each of these. And that's going to be kind of the format for each. So, and arguably decent memes at the start of each section. We'll see how those turn out. So, static analysis. Static analysis, when I did an earlier version of this talk and I asked, it was a room full of security people, and I asked, hey, what's the biggest static analysis report you've ever seen when you've run something like a Fortify or something like that? And a hand immediately went up and somebody from the back shouted out 13,000 pages from a run of static analysis. And I think it's not far off from what many people have actually seen, which is you will tend to turn on these tools. They will spit out thousands of pages of what turn out to be false positives. And what the security approach has typically been is to run that tool once a month, get a 10,000-page report, ship it over to the DevOps team or the development team and say, your problem, go figure it out. And the rational response to something like that, if someone's going to try to waste that much of your time, is to look at a few of them, see that they're false positives, and then flag any email from the security team that contains an attachment as spam, right? Because that's where we actually end up with the 99% false positive reports here. So that's how we've done it, because what we've traditionally done this as a super heavyweight process. We've turned on these tools and said, go scan our entire code base, not only the legacy stuff, but the new stuff, everything, and try to detect every possible type of vulnerability in that. And what happens? We get 50 million false positives out of that. But what we do, then we try to refine it over time. We'd spend 18 to 24 months actually refining that, getting it down to a point where, yeah, we got some decent issues out of it. But in a waterfall world, that was acceptable-ish, because if you're releasing every 18 months and you miss 2 releases while you're trying to get your static analysis tool to work, okay, like not really the end of the world. But if we're no longer releasing every 18 months, this becomes a huge problem really quick. So how do we actually adapt this? What we do is we shift from this really heavyweight top-down model to a really lightweight bottoms-up one. So I'm going to give you the methodology here, and then I'm going to give you an example, and then I'm going to give you 2 kind of unique ways that you can turn this problem on its head and get some really interesting results out of it. So the methodology is we start bottoms up. Pick 1 or 2 types of vulnerabilities that you actually care about, that are important to your business, and start there. Don't turn on a tool to try to go check for everything, because you'll end up with nothing. Start with 1 or 2 pieces and say, OK, let me scan for that. Now let me refine that down to when it's only finding actually real issues that I care about. Then I can go add on another one. Then I can go add on another one after that, and build it up over time. Because what you're really going for here is showing that something can actually run at the speed that we need it to run, which ultimately becomes on every code commit, right? If we can't run this on every code commit, really, what's the point? Or close enough to that. So rather than trying to say like all these different types of, in this case, web vulnerabilities, so SQL injection and cross-site scripting, command execution, and all these, pick the easiest to start. In this case, I talk about command execution because command execution, there's really only a couple ways it can instantiate itself in any different technology type. And I even do a sub-bullet about a sarcastic comment about grep, but it's only halfway sarcastic. That's actually pretty true. For most technology stacks, you can just grep for eval and system and get 90% of your code execution bugs right there. Don't tell the highly paid security consultants that. So start with just kind of the basic ones and build up from there. That's really how to actually enable speed with this. Because your focus is not only on findings, but demonstrating that something that was a really heavyweight and really slow control can actually modernize in the same way that we're modernizing our broader DevOps change. OK, the first of the two ways that we can actually turn this problem as well. So a really interesting thing that you can do is you can use static analysis. And that might be a big, expensive commercial static analysis tool. That might be some unit tests with grep. Doesn't matter. I'm just kind of using this as a broad overview. You can start to look for certain code primitives that should drive a conversation. It might be the security team. It might be your development team. It might be your architecture team. It doesn't matter. It just drives a conversation. So things that are inherently sensitive and rare, so things like hashing, encryption, a web app trying to touch the file system in some weird way, things like that. The old way that we used to do this is we do policies that said things like hashing, like so older hashing styles like MD5. And we'd say, OK, MD5 is old, it's broken, it's been broken for 10 years now. So if someone's trying to write code with MD5, block that code commit until they change that line of MD5 to say SHA-256 or something like that, a modern one. The problem is this doesn't give you any visibility into what's going on here. What's a better thing to do? So I'm not saying stop that. You don't want to allow MD5 in your code base. You still want to say, OK, use a modern hashing algorithm. But with any of these sort of buckets of hashing or encryption or file system ops, use this as a really good way to raise a yellow flag or a red flag to drive a conversation. So you can say, hey, we noticed that someone was trying to put hashing into the code base here. Let's use this to go talk to them and ask what they're actually trying to protect. When we first started doing this back at Etsy, I was like on the fence of if this was going to be useful or not. It ended up being tremendously useful because we would go to teams and we would say, hey, we noticed you're trying to do this. Like, what's up? Like, how can we help? And they'd say, oh, yeah, we're going to collect this whole new set of user data, which we had no idea about. We're going to collect this stuff, and we know it's sensitive, so we want to protect it. So we're going to do this hashing thing. And we got to say, oh, OK, we see what you're doing. First of all, glad we now know about this and that we didn't just learn about from a press release, which half your security teams find stuff out that way. So what we want to do here is say, oh, actually, hashing isn't the correct way to protect this. You can actually protect this with this whole other service that we put a bunch of work into where you don't have to manage any of the keys. It's one line of code to call anything out. It's way easier and faster and more resilient for you, and is better security from our side. And so it allowed those sort of conversations where those never would have taken place in the old model. And it actually turned out to be really effective for us. OK, the other one is knowing when, it's kind of a similar concept but applied in a different way, which is knowing when sensitive but rarely modified portions of the code base are being changed. So this is like the portions of for any applications out here, they all have stuff like this. There's kind of the role-based access control framework, or your session management, or custom encryption wrappers, whatever. Sensitive portions, like core business logic of the app, that typically gets written by very senior folks at the beginning of that app being created, and then almost never modified after that, because all the features you build on top of these core things. So you want to know when those core things change. Now, the old gatekeeping model of security would be, OK, wall off this portion of the code base, and don't let anybody touch it ever. You need 5 people to sign off before somebody can actually make a code commit here. The problem is if security does that, the first time that there's a outage where all of your SREs get paged or your developers get paged or whoever, and people are all on in a war room or something like that trying to deal with an outage, and they need to make a change to some critical portion of the code, and a security control pops up and says, no, 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 you need triple sign-off before this allows to happen. A, you're going to have a very bad next day as a security team, and B, all of those things are going to get ripped out. right? Because you just stood in the way in one of the most critical times of the business, and you furthered an outage because of a security control that actually didn't have that much benefit. So the way you turn this on its head is you say, great, when someone goes to commit code to any sensitive part of the code base, you send back a message into whatever your source control is, doesn't matter what the framework is there. You send back and say, hey, you're to the developer committing code or the infrastructure engineer, whoever's committing that, say, hey, not sure if you're aware of this, you're touching a really sensitive part of our infrastructure or of our code, and it is going to page these 3 people when you do it. And that's going to be the CTO, the chief architect, and somebody else. And what's going to happen is when you're in the middle of an incident, they're going to say, yeah, no problem. They're already in the room with me. It's no problem. But the intern who's editing the wrong code base sees that and is going to go, whoa, 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 wrong thing, back out, cancel the change. This isn't what I actually want to change. And so you're able to take these principles of how do I get visibility and alerting and coverage in a way that doesn't actually slow people down. And I'd say this is probably one of the best examples, I think anyway, of how to modernize security into the DevOps world, which is still get that same sort of coverage, but in ways that enable folks to move even faster. So that's the static analysis bit. Moving on to dynamic scanning. This meme has no relation to dynamic scanning. I spent like 5 hours trying to find a meme for dynamic scanning. If you can find one, you're a better speaker than I am. You've won the golden microphone or something. So let me know if you find a better one. So we used to do dynamic scanning was where we'd point scanners at our apps and say, go find bugs. Right? So it was like app scan was, I think, the IBM one or the HP one. I always mix them up. Web inspect and app scan were the big ones out there. And then there were some open source ones and everything. And so we turn those on, we'd run them at the app, and we'd basically say, OK, well, if it can find a vulnerability, we should go fix that. And occasionally it's even misused as pen testing, but it wasn't pen testing. So how do we actually adapt this? Well, taking a look at the applications that we deal with today, they look very different than the apps that were written in 99, 2000, 2003, these early kind of late 90s, early 2000s applications when the scanner technology was actually built. So modern apps are generally, because it's like single-page Java apps and super API-driven apps and things like that, whereas older apps were more very linear, right? Page 1, page 2, page 3. They had a couple form fields and a next button. Pretty straightforward, and scanners could actually figure that out and get through the app. But what I've lived and talking with a bunch of other CISO peers, the general consensus is really like, look, there's kind of too little bang for the buck on this control anymore, trying to run these scanners to go extensively figure out our applications and discover vulnerabilities in there. You can do it, you can make it work, but we all have so many projects going on that it was never really worth anyone's time, is what we've all kind of learned over the last few years. But you can adapt scanners to actually do 2 really cheap and effective things. One is ensuring that your security policies are actually being enforced. So you might have rolled out a policy that says, from now on, all of our APIs, all of our web apps, they're all going to be served over TLS, or SSL. And we're only going to support high-grade ciphers and above. And so you can take these scanners and just say, look, I don't need you to figure out all the nuances of the app. I just want you to crawl the app continuously and alert me if you ever see a link inside our domain that's just a plain text HTTP link. And now you can just have that run continuously through your CI system or even just on a cron job, really, and just run through and let you know if there's ever anything that's violating your security policies. And then the other side is an extra control on ensuring that previously discovered issues haven't regressed back into the code base. So somebody found a vulnerability, let's say a big, let's say a cross-site scripting issue in the search box on your front page. And so somebody found that, the development team fixed it, you pushed a fix for it, you pushed a unit test for it, and everything's great, and you move on. And then suddenly, a year and a half later, you get another vulnerability report that says, I found a cross-site scripting in your search box. And what? That was like a year and a half ago. We fixed that, and we added tests for it. Then what you learn in that is not only did that fix get rolled back via something else, but your unit tests were broken in that particular area. So what you can get coverage over here really cheap and effectively is point your scanners at known issues that you've had previously and say, hey, once a day, just go to that search box and try this exact exploit payload. And if it ever works, alert me, because I get 2 for 1 out of that. I get knowledge that the code got regressed in the code base and that my unit tests aren't working like I expected. So it's really cheap and effective ways of actually turning these controls around. All right, security visibility. This Twitter account is a sarcastic Twitter one of like ops things that we've all lived, and it's painfully accurate. Yeah, I hear a knowing laugh in the audience there. Yes, there are some very accurate, painful ones on there. All right, so let's talk about how we've had security visibility in the past. It's pretty short. We haven't, basically. We've had all these different silos of data. We've had logs, we've had customer support outages, or customer support reports, outages, things like that. Each of these things was completely siloed inside an organization. So how do we actually start to invest in here and modernize here? The good thing is this is not something where security has to reinvent the wheel. Security basically has to learn the lessons of the DevOps movement in the last 5 to 10 years, which is take different sets of data and bring them together where everybody can have the context into what's going on. It's really taking data that was operationally relevant, development relevant, and security relevant and bringing it together. So I'll give you an example, which is this is a thing that made this whole scenario so tangible to me, is we took this graph, so just generic web errors graph, right? 500s meaning something's broken in the API or the website or something like that. And we went and asked a whole bunch of different parts of the organization what this implied. And you get completely different answers. It was fascinating. So we'd ask a development team, and they're like, oh, yeah, we have a new engineer on the team who just started. They probably didn't really know our stack, and they broke something and rolled it back. And then we'd ask the DevOps team that, and they'd say, oh, it's probably that one development team over there who's paged me 5 times this week at 3 a.m. Yeah, I'm not looking at any more, I'm not responding to any more on-call pages this week because of that. And then we go ask our security team, and they'd say, huh, that's interesting. I wonder if that's somebody actually discovering a vulnerability and figuring out how to make their exploit payload work before they actually succeed at stealing data there. And if you're ever fortunate enough to ask your attackers or your adversaries, you will hear from them, oh yeah, that was me discovering a real issue and figuring out how to make an exploit work before I actually was successful at it. And so what we learned out of that is, hey, we need to take data that is clearly lacking in context and bring security relevant context to it, so that now any one of those groups can look at these side by side and say, wait a minute, that errors graph that I thought was X, why is that happening at the same time that we're seeing more attacks than we've ever seen? And that, bringing that context together now means any of these groups can look at this data and say, there's something going on here. And that's really the best that you can hope for, is to give people enough context where they can recognize there's something actually happening here, and we can start to dig in. All right, moving on to feedback. If you think it's terrible that I put an Office Space meme in a slide deck in 2018, it's because Office Space is now 19 years old. So first of all, I feel ancient, and B, that qualifies, I think, as a vintage meme at this point. We're allowed to bring it back into slide decks. All right, so feedback. How we've had feedback in the past is basically pen tests. How many folks have lived through a pen test, a security assessment, something like that in your words? Yeah. Most of us, right? The problem is that they're typically done annually. You bring in the pen testers. It's typically 1 or 2 people for 1 or 2 weeks, and you're stuck with this really terrible choice, which is, do we have them try to go really broad but very shallow, or do we try to have them go very focused but only in one tiny spot when we know we need coverage over a lot of different stuff? And so it ultimately really only answers this question, do I have bugs? And the answer is yes. The answer to that question is always yes. It's software development. We all have bugs all the time. But when applications were only released once a year, once every year and a half, and we got some feedback out of that, it was kind of fast enough. So how do we actually modernize this? What we do is we do this through the combination of pen tests and bug bounties. I'm going to take a second just to define bug bounties for folks in the room that maybe aren't familiar with it. Bounties are really interesting. It's where you basically put out a SLA on your website or somewhere, and you say, look, attention security research community. If you discover vulnerabilities in our sites or services or products or anything like that, and you play by these kind of Good Samaritan rules and report the issue to us, we will reward you in some way. So if you act in good faith, we'll act in good faith. And that reward might be monetary. It might be a thank you like card or T-shirt. It might be just a name on like a thank you page or something. It can be, oftentimes it's all of the above. And so bounties, the reason for that, which seems pretty straightforward, the historical context is for most of the last 20 years, if you were a security researcher and you discovered an issue in some company and you reported that, you had 50-50 odds of getting sued. And so, yeah, it's crazy. 50-50 is being generous, too. So what researchers would do, it went into this like horrific lose-lose scenario for both, where researchers would discover an issue and they'd say, well, I care about getting this fixed because this is going to impact real people. So what I'm going to do is anonymously publish it with the full details so that the company can panic and eventually fix it. But I know it'll get fixed and I won't get sued because they don't have my contact information. And so this is basically, I just summed up vulnerability reporting for the 90s and most of the 2000s, was that model. And so eventually, after 20 years, we all as an industry kind of figured out, hey, maybe we can do a better job than utter disaster. And so what we did is we came up as an industry with this bug bounty approach, which said, hey, you play by our rules. You only look at these services that we define as in scope, and you look for these type of things that we define as in scope, and then report it to us. Great, we'll reward you in some way. Win-win for everybody, awesome. And so these are really taking off. These have exploded in the last several years. And occasionally you'll see like some marketing stuff around, oh, you can replace pen tests with bug bounties, or you don't need a bounty because you have a pen test or anything like that. I've lived on all sides of these. As a pen tester, as a CSO, where we launched one of the first bounty programs, I really like having both of them because they play to each other's, their strengths play to each other's weaknesses. Where now you can use your pen tests for really focused areas on a new infrastructure project or a new development project and really have them deep dive on something. And you can have your bounties operating continuously across a broad but fairly shallow in general bit of your services, and you can get this continuous feedback. And so that's the really important bit is if you start to think about getting visibility, then you need to combine that with continuous feedback. So lots of, I ruined the punchline already, damn. Lots of security speakers take themselves very seriously. I do not, so rather than being a thought leader, I've got thought leader Hosen on a slide, which if you thought that joke was bad, it bombed in Germany. Not a single laugh in the room. In fact, someone just kind of looked angrily at me for a minute, like, okay, cool, moving on. All right, so what are, kind of entering the final broader section here, what is the, what am I seeing as the combination, or the commonality between organizations that are making this shift really effectively? It's the combination of focusing on visibility into these systems and continuous feedback. And so when you look at it this way, think of it from kind of a attack-driven defense perspective, which is if you want to be successful against real attackers and real adversaries, you have to be able to answer the question, how do I know when my attackers are being successful? The first time you ask yourself that question, you're like, oh, I know. And then the second and third time you ask yourself that question, you're like, well, what about? And the more that you poke at it, the more that you realize almost nobody, when they first ask that question and start on this journey, can actually answer that question today. So we can do better. And this is where I think that security, which is usually very doom and gloom and sees change as the enemy, is really wrong on this. I think that embracing DevOps and cloud can actually make us much more secure than we've ever been in the past. And there's kind of three key reasons for this. Number one is that when you go through this shift in general, there starts to be much more investment into visibility and what's going on in your systems. You see the rise of Datadog, AppDynamics, New Relic, all of these things that brought visibility to a previously specialized area and brought that capability to the broader organization. Security is just starting to learn that lesson, that bringing visibility like that really helps everybody. And so by investing, because we tend to invest in visibility during this shift, it allows us to detect attackers earlier in the attack chain. You don't want to detect your attackers because you just got called by a newspaper for comment as to why your user database and credit card details are up on the public internet. You want to detect them earlier than that, and investing in visibility is how you do it. Number two is it gives you the ability to continuously test and refine your triage and response approaches. So just like kind of operational game days, there's a bunch of terms for these things, but where you run kind of readiness exercises on the operational perspective, for everyone who's familiar with Netflix's kind of chaos monkey approach and everything like that, right? You don't want, it's basically, you don't want the first time that you ever test the fire alarm to be when there's a real fire. You want to test it every now and then and make sure that it actually works. Same thing applying to security. Starting to run these game day exercises, and if that's interesting at all, I've got a full talk just on that one topic alone of how you do them really effectively. But you start to run these simulations that say, okay, if we discovered an issue, if an issue got discovered in this sort of service or in this sort of scenario, what would we do and who would we talk to? And the next sentence is going to be kind of just a blank stare usually after that, because you're like, okay, well, actually the team that wrote that got repurposed like 3 years ago, and actually half those engineers have left. Who even owns that code? What do we do? And so you don't want that to happen when there's the middle of a live security incident going on. You want to run these scenarios ahead of time. So you go, oh, actually, this person doesn't own it, but they're the one who actually know a lot of details about it. We can go to them, and they know that we can come to them with any security issues. And then the other side of it is to continuously test and refine your security operations, incident response, security ops approaches, where what you can do is you can say, let's take a benign discovery. So that might be something that came in from a well-intentioned security researcher as part of a bug bounty. It might be a vulnerability discovered in a pen test. It might be something that one of your DevOps engineers discovered something and said, whoa, actually, that is a massive vulnerability that we've got in our infrastructure. Take that and run it as if it had been malicious. Run a scenario that said, how would we have detected if somebody was exploiting this? How would we detect if somebody had discovered this? How would we know that somebody hasn't actually discovered it for the last 8 months and has been abusing it up until now? And the first time that you ask yourself those questions, you will not like the answers to them. And that is the best type of question you can be asking, because it tells you where to invest and what to be thinking about. We ran through that a bunch, and we were, I'm not too proud to admit, the first couple times we were like, oh, we'd know. Like, we've invested all this in this operational visibility. Like, we'd totally spot stuff like this. And then I brought in this attack simulation team where I said, look, unlike traditional rules of pen testing where you're going to tell us everything in advance and let us know all this stuff, I want you to run wild. I want you to not tell my team anything. They're going to know that you're going to be here, but they're not going to know any details. And I want you to try to get production data. Go. And it was 2 days in, and I was like, man, they are slow. Like, they haven't tripped off this alarm yet. They haven't tripped off that alarm yet. Like, they're taking all week, apparently, to do something. And then they pulled me into a room and were like, oh, yeah, here's your full production database. I'm like, shit. And run that scenario several more times. And what you start to learn out of that is not only where you need to invest, but how to be thinking about these questions of saying, like, how would we have detected this? How would we know that somebody else hasn't been exploiting this for 8 months? One of the scariest moments of my entire security career, actually, was on a very similar thing, where we had run these scenarios a bunch. We had invested in a bunch of visibility for the application layer and the API layer. And we had an incident. I'm going to talk about another one like this. That's a good story. This one's a scary story in a second. But this one, we detected somebody discovering a vulnerability in one of our services. And it was a pretty good vulnerability. And we watched them discover it. We could tell it wasn't automated. They were doing stuff by hand. They discovered it. They poked around for a while. They figured out a working exploit for it. And then they confirmed that exploit. And then they stopped and went away. And they never reported it. And they didn't come back and use it for months. It was absolutely terrifying. This is like the security boogeyman story. It's just like insanely terrifying. And we never would have known about that. We were able, because we detected it, we figured out what it was and we fixed it. But we never would have known about that if we hadn't been asking ourselves these questions and starting to actually think about how do we get this visibility. And so this is one that they were clearly saving up because they figured it was going to be way more valuable down the line to exploit us at some point than at that point. But it just really hit home about this. So I'm not going to end on a scary note. I'm actually going to end on a good one, which is a different version of that story, which unrelated, which this is actually public. It's up on Reddit still, as far as I know, where we had a security researcher discover a vulnerability. And again, we had been investing in this a bunch. So we were able to detect them discovering a vulnerability. And then we were able to push a fix for it before they reported the issue to us. And so they were the security researcher. They were working on it. They figured out an exploit. And then they came back like a few hours later to test their exploit again. And it wasn't working. And they emailed us, and they sent this really cool email. They were like, hey, so I'm a very legitimate security researcher, and I discovered a issue in your site, and I noticed it suddenly stopped working. I can't imagine that's a coincidence. By the way, I was testing for my home IP address. Please don't sue me. And so we actually had this really great back and forth with them, where they sent us a bunch of cool details. We built this great relationship, and they ended up sending us a bunch of really good stuff over time. But it was a really exciting thing. And the reason that I put this in here is not because, oh, we were so cool or something like that. It's the opposite. It's that this was a real kind of light bulb moment for me around recognizing that shifting to DevOps, shifting to this broader kind of increase in velocity can actually make us safer, A, because we can invest in visibility, and B, because for the first time we actually have the ability to react. This is what's so different. So getting to the end here, kind of wrapping it all up, we're going from this model of security as a gatekeeper that views its job as total, it has to sign off on everything. That doesn't scale. It doesn't keep up. And so trying to eliminate all bugs before they ever make it to production, it just doesn't scale. So what we're transitioning to, and this is what I would encourage you to take out of this, hopefully, is that with your own security programs inside your own technology teams, be thinking about how can we be adapting our security programs to focus on giving us continuous feedback and continuous visibility so that each team can ultimately become security self-sufficient. So you're awesome for sticking around. Thank you. I don't know, how far over am I? Do we have time for questions or? Totally. So the question for everybody else in the room was, I had given that example of alerting on sensitive parts of the code base changing, and the rational question after that is, great, but your slide implies one code base. What happens when you're actually at scale, right? You've got 30 or 300 or 3,000 code bases. You take that same model, but you apply it rather than a central security team who does this for each individual code base, because they'll never know, and they can't scale. This is all kind of part of the broader security shift, which is that it only goes if it brings those capabilities to the other teams. So you find security champions inside. Either you find the champions in there, or you train people up to be security champions inside these different teams, and you say, look, a really effective technique is to alert when your sensitive code base changes on these particular spots. Here's the overall approach and technique, and here's maybe some tooling that can help you out. You figure it out for your particular code bases. And so you scale via the different teams. In the old model of security, it was highly centralized, and that doesn't scale. It's got to decentralize down into the individual teams. And the central security team's job is really providing tools and techniques that are a shared service across everything. Does that answer your question? Awesome. Yeah.
Something so complex that you can't just look at a core service in some little thing that gets driven. Some of my customers are doing deep analytics on change to like patterns, and so I think that's really interesting when you start looking at the kind of aggregating things that happen versus changes, and you get the gravity of
the kind of the sensitivity of the change that's happening. In fact, you can even do the inverse. I didn't have time to include this, but you can even do the inverse, and you can say, alert me about things that have never changed, right? You see some really spectacular vulnerabilities that come out of bits of code that are publicly reachable but haven't changed in 10 years. Those are terrifying bits, for sure. I can tell you from experience. Other questions, please. Bar time. Yeah? All right, one in the back.
How do you get security teams to be invested with the DevOps instead of just wanting to stay at
How do you get security teams to change and kind of come together with the DevOps teams? Well, my very flippant answer would be, either they can show up to the party or not. The real answer actually is what I see be effective, and this is the advice that I give security teams, is kind of the other side of this advice is like, look, development is modernized. Software delivery has gone through a generational change. Software development has gone through a generational change. Software delivery has gone through a generational change. Security has to go through a generational change as well. And so that doesn't start with technology. It starts with culture. Right? And so going to those security teams and saying, look, we are modernizing and we care about security. Like, this is the number one thing I'd go to a security team and say is, like, we care about security. We are deeply committed to making the services, that the applications and services that we're putting forward be secure. But the flip side of that is our ask to you, which is that you've got to help enable us to go fast. Because we're going fast no matter what. We need your help in doing that securely as well. And the answer can't be slow down while we check everything out. It doesn't scale. And so we need your help. And we recognize that, like, there's going to be missteps along the way. And this is the advice I give to security teams from their side, is saying, like, look, go to these teams and talk about how you're committed to modernizing approaches to security. You're not going to get it right the first time, right? There's going to be plenty of technology missteps, plenty of cultural missteps even along the way. But if you can't start with that high-level commitment from both sides that says, we recognize massive change is happening, and both sides are committed to the end goal, which is moving faster and securely, then no technology on the planet is going to save you, right, if there's no buy-in for that. So, good question. Thank you. All right. I'll be around this afternoon. Please feel free to heckle me in person or any other questions. Thank you so much. All right.